Well, first of all, may I thank Peter and David and Paul and everyone at the Scientific and Medical Network, which I was a member of for many years, and then I lapsed. And now I'm coming back home. Talking of coming home, it does feel that this is the time for us to remember, as someone said earlier and last night, remember who we really are. And so I'd like to share with you today this book that, as I mentioned last night, I've been wanting to write for 60-odd years, since I had my first multidimensional experience. And I'm sure, as Ravi would agree, our journeys, our lives, our explorations have taken the scenic route. I started as a coal miner's daughter who looked up at the universe when I was 4 and 5 years old and studied ancient wisdom from then with my discarnate teachers. Did the physics, did the cosmology, did the archaeology, did the international business career, scenic route. So I speak as one who's been bruised, bloodied, uplifted, empowered by this scenic route of mine. And what I'm very joyful about is that the science has, as a mystical scientist and scientific mystic, I'm delighted that the science has finally caught up or trying to catch up with the mystical and spiritual experiences that as humanity we have had from the get-go. So let's begin. Our informed and holographic universe. I spell informed as in-formed, and I'll explain why as we go along. This isn't random data we're talking about. This is information, patterned, intentional, purposeful information. It is consciousness at play, as I hope I'll be able to share with you as we go along. Recent scientific discoveries are showing that information is more fundamental than energy and matter and space and time. Now, essentially, our world looks very solid, yeah? I fell down the stairs a couple of years ago and slammed into a brick wall, and I tell you, at that point, it was very, very solid. But I know as a physicist that literally all we call physical reality, if we drill down to subatomic particles, is literally 99.99999999999% nothingness. And what remains are mere excitations in the field of information, which is our universe. Now, what's been really exciting is that some years ago, there were theorists like Leo Szilard and Rolf Landauer who postulated that information was as real as any physical entities. They identified theoretically that if a digital bit of information, the same bits that underpin all our technologies, was actually deleted, an amount of heat would be released. And they specified what that amount of heat would be. And of course, heat is as physical as we get. I'm heat now. But essentially, that was theoretical. It was only in 2012 where there was an experiment by a team led by Antoine Berroux and Eric Lutz, who were able to show for the first time that that's exactly the case. When one digital bit of information is deleted, there is an amount of heat dissipated. And it was exactly in line with what Szilard and Landauer had hypothesized. So in doing that, and that's pretty recent, 2012, by doing that, they were able to link information with anything we call physical. And as I'll go on to explain, what is being realized is that information is more fundamental than energy and matter, and more fundamental than space and time. Indeed, the energy, matter, and the space-time of our experienced universe emerges from deeper, super-physicalized fields of informational patterns and intention and essentially consciousness. So our universe is literally, it's not metaphorically, it is literally informed. And what is also being shown, I'll come back to this in more detail in a minute, but I just want to sort of set the scene for you. Many fields of scientific research, from the very smallest scales, from the cosmological scales down to the Planck scale, which the Planck scale I'll come back to too, but it's almost unimaginably tiny. Nonetheless, it has been seen as the scale of pixelation of space-time and physicalize reality itself. So from that scale to the scale of our entire universe, and every scale in between, including that of our everyday lives, is being shown to be innately informed. And even more, that it is holographically realized. And when you actually look at our universe and the physical expression of consciousness that our universe represents, everything hangs together. Instead of 100 years of science not being able to reconcile quantum physics and relativity theory, because quantum theory doesn't have any notion of time, and relativity theory has no notion of quantization, we start to restate the laws of physics as informational algorithms, essentially instructing our universe how to exist and evolve. And when you do that, voila, I like that word, voila. Quantum theory and relativity theory are hand in glove, because what they are complementary expressions of information. With a single bound, we are free. I love that. So what this is also showing, of course, as Ravi so inspirationally led us through, is this is a whole worldview. This allows for the diversity, the uniqueness, the diversity of ourselves as microcosmic co-creators of an ultimate cosmos, of infinite mind, that oneness, and yet we can play, we can shout at each other, we can love each other, we can inspire each other, we can go on a journey or not go on a journey. That's what it's all about. So just to repeat that information is physical. We know that, we've known as physicists, it's almost like being the secret to most folks, that actually physical reality is incredibly ephemeral. But also that now we know that information is as physical. Now, I've mentioned Szilard, Landau and the experiments of Baruch and Lutz a few years back. I'm going to go on to another hero of this emergent perspective, Claude Shannon, in a little while. But what that is showing, that information is more encompassing than energy and matter. When Isaac Newton first came up with his perspectives, they're still what we guide satellites by. They're still what we do rocket science with. But then Einstein came along and said, that is great, but actually we need to expand our perspective. What this is doing, it's not throwing out all the science of the last 300 years. It's expanding on it. It's restating and expanding on it. And when we do that in informational terms, because what we're doing then is instead of peripheralizing consciousness, we're bringing consciousness into the not just the center, but the be-all and end-all of reality. Then suddenly science gets simple. Suddenly science becomes mystical and mystical becomes science. And there really is no, it's a conflagration, it's an integration. And the mathematical formalism is there. I was asked by a cosmologist a year ago, well, okay, this sounds great, but where's the mathematical formalism? And I said, it's all there. It's the laws of thermodynamics. It's quantum theory. It's relative. All I'm doing is translating it. As an archaeologist, I also know about the translation of the Rosetta Stone that was able to translate Egyptian hieroglyphics. This is a translation of reality into an all-encompassing, conscious, whole worldview. So, we need to take another step forward, because for many, many years, there was a debate amongst cosmologists. Is our universe finite? Is it infinite? Does it extend beyond? Etc., etc. The most recent evidence and discoveries of cosmologists are suggesting very, very strongly that our universe is indeed a finite entity. It was born 13.8 billion years ago, not in a big bang, which wasn't big, and it wasn't a bang. For me, it was a big breath. Because when we go back to that first moment of space-time, our universe was incredibly ordered, literally as simple as it could be, but no simpler. Like a newborn child coming into exploration of consciousness. So there was a finite beginning, and because we know from relativity theory that space and time are each relative to the observer, but when they're combined together, they form invariant space-time. And that's crucial, because without invariant space-time, we couldn't agree on anything. the laws of physics wouldn't work. We need relativity theory to combine space and time into invariant space-time for our universe to exist and be able to evolve. So there's a finite beginning, not just in terms of time, but in terms of space. We also know from the antique relic of that first beginning of the out-breath, the big breath, the cosmic microwave background, when we look at the wavelengths of that, they are finite. There's a finite cutoff. Now, a finite cutoff to the heat emanating from a hot oven gave rise to quantum theory over 100 years ago. Because until then, people thought, well, heat's radiating from an oven, and on the equations that were there then, there was no way for that heat not to be infinite. It was only when Max Planck and then others realised that heat is quantized, energy and matter is quantized, that infinite impossibility became a finite possibility, because there were finite wavelengths, cut-offs to the heat from a hot oven. We now have the same on a universal level. There's finite energy coming out of a finite beginning of space-time. Quantization itself, if you think about it, why would energy and matter be quantized? Well, as I'll explain as I go on, if we think of information, all the possibilities that then become finitely expressed within our universe, quantization's perfect. It's not about qubits and all possibilities, it's about digital bits of information as finitely expressed. So quantization is the simplest, easiest way of doing that. And you can't have infinite energy matter within finite quantization. So that's another clue. Stellar formation's fascinating. A few years ago, a team led by David Zobral looked at the way in which stars are formed. And what he was doing is he was looking at something called the H-alpha spectrum, which is a very powerful indicator of stellar formation. And he looked out into space 2 billion, 4 billion, 6 billion, 9 billion years back, further out, further back in time, and realised that over 95% of any stars that could be formed in our universe have already been formed. Our universe is now in her menopausal state. And I think she's probably on HRT, but I wouldn't like to ask her. The thing is that all of these are clues to our universe being finite in space and time. And yet, we also know, and David mentioned this, I think yesterday, about something called Bell's theorem. Now, Bell's theorem is something that says basically our universe has to be innately, non-locally interconnected. In other words, exist and evolve as a coherent entity for quantum theory to work at all. And what we've now found is that there was a team led by, I think it's Charles Kaiser, very, very recently, that's measured Bell's theorem, or Bell's inequality, out to 600 light years. So we know, as far as we can measure experimentally, we know that Bell's theorem works. Theoretically, it has to work for quantum theory to work. And over 100 years, there's been no experiment that's misproved anything of quantum theory. It stacks up pretty well. So again, we're coming to this perspective of a finite and yet coherently interconnected universe. And by the way, when I talk about a finite universe, I'm not talking about a finite cosmos. I'm talking about our finite universe, essentially, as we'll come to it, but just to have a sense of this, as a finite thought form in the infinite, eternal mind of the cosmos, with a beginning, just as we have thoughts that have a beginning and an end. Our universe soul is the evidence and the discoveries are all converging to this perspective. Also, to add to this, is that our universe appears to be a closed system, spatially and all that suggests, I mean, it's flat to 1 part in 10 to the 62 at the first moment of the big breath. It's flat, it's closed, and so it can, all things are pulling together that it exists and evolves as a finite, unified, coherent entity within the mind of God, within the mind of Brahma, however we want to define and describe it. So, on all that basis, within an infinite cosmic plenum, the other thing that's coming forward is more and more evidence to suggest that the simplest shape for our universe, and remember we're talking thought forms here, we've gone past physical, this is physicalized realization, but as information, suggests a torus. A toroidal universe enables, it's the simplest it can be for a closed, finite system where everything we know about the laws of physics, which we can now expand to algorithms, instructions, informational instructions for our universe, can work together in the simplest way possible. So I mentioned earlier the Planck scale because we need to take a couple of other considerations into account before we can bring this recipe for the perfect cake of our universe together. And one is the Planck scale. When we drill down into the fundamental forces of our universe, something called the Planck scale, named after Max Planck, just naturally falls out. And there's a scale of mass, which is related to the smallest black hole. There's a scale of heat, which is the temperature of our universe at the first moment of the Big Breath, 13.8 billion years ago. And there's a scale of length and a scale of time. The scale of length is 10 to the minus 35 meters, which when you consider that an atomic nucleus is probably about 10 to the minus 16 meters, is unimaginably tiny. But even more so is the scale of time, which is 10 to the minus 44 seconds. I just wish we'd have time today, and maybe we will later, to just tune into this, because this is the pixelation scale of the cosmic hologram of our universe. This is the pixelation of space-time at the tiniest, tiniest scales through which the reality of our universe is expressed. I mean, how many of you remember seeing TV screens which were before the sort of the modern ones, and you could actually get, well, I could because I go that far back, you could actually look at them and see the pixelation on the screen. It was so rough, it was visible. Does anybody else remember that? Please join me. Let's see a few more hands. Please join me. Thank you so much. You can't now. But if you think that the pixelation of space-time is 100 trillion times smaller than the highest definition of our leading-edge holograms, that's what we're talking about. So we need to have the final piece in all of this before we pull it all together. And the final piece came out of understanding black holes. And essentially, like a hologram, if you think of a hologram, and for me, holograms were discovered, not invented, by Dennis Gabor in 1947. And what a hologram does is it takes a beam of light, it splits it into two, it bounces one beam off an object, it could be an apple, it could be a PC, it could be a person, recombines them on a two-dimensional photographic plate. You then send a beam of light through that holographic patterning, and that creates the appearance of the three-dimensional object that was originally reflected from. And what is amazing about a hologram is to the lowest level or the finest level of its pixelation size, if you slice and dice it, the whole of the object will repeat in every pixelation. Yeah? But what was being found, so of course what you get is this three-dimensional appearance of a hologram from this two-dimensional patterning of information on a photographic plate. When folks were studying black holes, they were trying to understand what happened to the information when a star collapses into a black hole and goes below the event horizon, which is the sort of the black surround of it where light just about can't escape. What happens to all the information of that star? Because there's something deeply wrong with it being destroyed, because it actually affects the reality of quantum physics and lots of other laws of physics in our universe. And what was discovered is that that information is actually retained on the surface of the event horizon of that black hole. Now, what you'd think, if I pick up a book my own book, you know. If I pick up a book, if that book was thicker, you'd expect there'd be more information in it. You'd expect the information in the book to be proportional to the width, the height, and the depth. Yeah? The point with the black hole informational content is that that is not the case. All of that information is proportional to the surface area, the spherical, in the case of a black hole, the spherical surface area of a black hole, so that it completely resembles a hologram. You have all the three-dimensional appearance of information, but held on a two-dimensional surface area. And Israeli physicist Jacob Bekenstein calculated that informational content and showed that the information was held at 1 digital bit for every Planck scale area. So the larger the black hole was, the greater the informational content, but it was proportional to its two-dimensional surface. So if you think of, say, a balloon, okay? And if you were to actually mark little triangles, because Planck areas are triangles, on the surface of a balloon, and you put a little dot in each of those triangles, that would represent the informational content, not just of the surface of the balloon, but the balloon, the appearance of the three-dimensionality of the balloon. You then blow up the balloon, but instead of the, you know, when you do the elastic stretches and the areas get bigger, it doesn't happen like that. The areas stay the same, but more information can be held on the surface. So those little triangles stay the same as the balloon grows, but there's just more information able to be held. Now, incredibly, what cosmologists then did is they extended the understanding of the informational content or entropy of a black hole to our entire universe. And this is called the holographic principle. Now, if this was just being shown as cosmology, then you'd argue, very interesting, but what did it have to do with me, and is it real? What I want to go on to do is to show you how it's real, how all that we experience and understand and explore as the physicalized manifestation of consciousness we call our universe is innately informed and holographically realized, and that we can consider that that emerges essentially from a holographic boundary, almost like the bubble, the thought form bubble in the mind of God, the mind of the cosmos. So these are the key aspects and one premise for our universe. Key aspects, and this is supported, as I've gone through already, by cosmological and actually a lot more evidence, that our universe is spatially, geometrically flat. Otherwise the laws of physics couldn't work, E wouldn't equal mc squared, etc. It's finite and closed in both space-time. Space expands, as we know. Time flows. And I want to come back to the nature of time a little later on this, because this all stacks. And information is as physically real as anything we call subatomic entities. In fact, subatomic entities and the whole of what we call energy matter of our universe is information expressing itself in that particular way. Now, the key premise of our universe, and again this is supported by theoretical framework and evidence at multiple scales, which I'll go on to in more detail, is that it is holographically manifested, with digitized information pixelated at the Planck scale area of the holographic boundary, or brain as it's often called. Spelt differently, but brain of space-time. So where does that lead us? I want to sort of go into a bit of this restatement stuff, but very quickly and very simply. And for anyone who wants to go through it in more detail, I'm around the rest of the conference, and I bought a page called This New Insight that tracks the laws of thermodynamics to laws of information, and in the way to that reconciles quantum theory and relativity theory, and it's all on a page. So we'll get to that. I call it a new insight because we're talking about informational science. And this is a call not just to physicists, but by restating and expanding the laws of physics as laws of information, We can look at informational biology, informational ecology. The book is full of those sort of examples. Informational, looking at social behaviours. Again, we're looking at this at every scale of existence, and crucially, at the scale of our everyday lives and our collective choices. So by doing so, we have the laws of physics as informational algorithms, instructions, enabling our universe to both exist and evolve. And by restating and expanding the laws of thermodynamics as laws of infodynamics, as I say, we can reconcile quantum relativity theory, and we can show that information expresses itself in complementary ways as energy, matter, and as space-time. So let's take the first law. Can I have a show of hands for who knows what the first law is? Oh, for goodness sake. Good Lord, people, where did you go to school? Basically, there are two main laws of thermodynamics, and they both go back to a wonderful and actually very troubled researcher called Ludwig Boltzmann. And I'm so glad that he is now being vindicated for everything, because his laws of thermodynamics are, as I'll show, the fundamental nature that leads, when you expand them, to an understanding of our universe. So the first law of thermodynamics says that the energy in a closed system, and such as our universe is conserved. In other words, it can change its form, but it's always the same. It just changes its form. So I hate to tell you, especially the ladies amongst us, that we are all 13.8 billion years old. All of the energy matter that's in the form of our physicalized bodies was there at the get-go. Then it was hydrogen. But the exquisite nature of the laws of physics, how they relate to each other, how the algorithms of the infodynamics of our universe enabled the ever greater evolution of complexity to this point. Nonetheless, our universe exists because of this conservation law. So when we take that first law of thermodynamics, which is all about gases, and then we go on to what quantum theory showed us, which was that energy and matter are equivalent, we then get to the energy matter of our universe is conserved. Now, this is the most basic, simple expression of quantum theory, because quantum theory does is it describes how energy, matter behave. It has no notion of time. Yeah? It's all about quantization of energy, matter. So if we take the first law, we get to that point with the equivalence of energy, matter, and the conservation on a universal scale. So repeat it through to quantum theory, but then add information can be expressed as energy and matter. So the information expressed as energy matter in our universe is universally conserved from the beginning of the first moment of the big breath through to its finite completion. This is the first law of information. We then need to look at a different concept which is completely complementary to the laws of thermodynamics and the laws of information, which is the idea of entropy. Now, entropy, for most of us, we were taught that it's about, well, actually on a formal level, it's the number of microstates of a system. But it's often viewed as levels of order and disorder. And any mother or father who's got a child will know entropy intimately, because the child's room is tidy possibly at the beginning of the day. At the end of the day, disordered. Order to disorder. It just happens. Order always trends to disorder over the flow of time, and it's the flow of time that's key to this. And I'll come back to that in a second. But Ludwig Boltzmann described entropy in this very simple equation. S is entropy, K is a constant named after him, and log W is the W is the number of microstates. There's this all logarithmic. Logarithms scale up, scale down. They're innately holographic. Now, what is key to all of this is that Claude Shannon, who was an IBM communications engineer, discovered exactly the same equation as Boltzmann had discovered 100 years or so earlier. But instead of the microstates of the energy matter of a system, Shannon realised that exactly the same equation describes the informational content of a system. So in that respect, that simplistic order to disorder, it's actually fewer microstates to more microstates, but it's actually boring to interesting. It's actually simplicity to complexity. And when we expand thermodynamics in this way and with this revised perspective of entropy, we start to look at what's called the second law. Now, the second law says the total entropy of a closed system, such as our universe, always increases over time. And cosmologists such as Brian Greene and others have sort of gone back to that first moment 13.8 billion years ago, realised that universal entropy was at its minimum. And because entropy always increases over time, that was the way they understood the flow of time itself. But that isn't sufficient. What we need to look at is when we move the total entropy of a closed system, always increases over time, we get the directional flow of time, we get the second law of thermodynamics. But then, when we integrate, which we have to, space and time, we can't consider time of itself. We have to consider time as being part of invariant space-time. Then what we get is the total entropy of our universe always increases over space-time, which again cosmologists have understood for a while, hence Brian Greene and others, but this is the simplest version of relativity theory, because that's what relativity theory does. It looks at relative space-time, it looks at invariant space-time, and it realises that for our universe to evolve, that its entropy has to increase from the first moment 13.8 billion years ago ever since. But of itself, that's insufficient because that's still treating space-time as the absolute reality. If, though, we take Shannon's add-on to Boltzmann's insight and realise that the definition of entropy expanded is the informational content of a system, then the information expressed entropically always increases over space-time. Second law of information. Information universally expressed as energy matters conserved. Information universally expressed entropically as space-time always increases. The first law is an expansion of quantum theory. The second law is an expansion of relativity theory. The thing is, what this does is it reconciles them. Because just as the first and second law of thermodynamics are complementary expressions, so the first and second law of information are complementary expressions of information expressed as energy matter and expressed as space-time. The first law, expressed as universally conserved energy matter, information expressed in that way, enables our universe to exist. The same energy matter from the get-go to the end, just changed in form. But it talks nothing about evolution. It's the second law, with the flow of time and the holographic expansion of space being crucial to its entropic expression, and thereby increasing the informational content of our universe, that the second law allows our universe to evolve. I'll just go back for a second and bear with you on that. This is one page from thermodynamics via quantum relativity to a universe that now we can understand as innately informed, holographically expressed, as a non-locally interconnected, coherent, unified, finite entity, existing and evolving as such. A thought form in the mind of Brahma, the mind of God, the mind of cosmic mind, as Einstein called it. The flow of time itself, at that Planck scale interval, is our universe thinking. Space, as it expands at every Planck scale iteration, is our universe breathing. I just want to tie up an apparent paradox here, causality and coherence, because the flow of time within space-time is the entropic the entropic increase of informational content, allowing our universe to evolve from simplicity into ever greater levels of complexity and self-aware microcosmic expression within space-time, because nothing can go faster than the speed of light within space-time. And yet, so nothing violates causality. And of course, if you think about informational entropy, always increasing, then if you think about it, as Ravi said, an effect always holds more information than the cause. Because the effect, the cause in the past, there's always less informational content in the past than there is in the present, that there will be in the future. So that informational entropy is always increasing. An effect will always have more informational content than the cause. And even if you go round and you clear the kids' room for tomorrow, there is still the history. There's always still the Akashic record of our universe saying, well, it was disordered last night, and I'll do it again, and it'll be disordered tonight. But always, 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 that increase in informational content. So causality enables within the appearance of space-time for cause and effect, for choice and consequence, for playing out of evolutionary perspectives with each other and the whole world. And yet, Bell's theorem, experimentally shown out to 600 light years and required for quantum theory to work at all, shows that our universe is non-locally coherent. Now, what this does in its entirety, and what the two laws of information, infodynamics, show in their entirety, is a whole worldview which doesn't just explain our physicalized experience, but it incorporates all supernormal phenomena. Telepathy, remote viewing, precognition to a point. We can talk about that if you'd like to later. But all supernormal phenomena and all universal spiritual experiences at many, many different levels, with many, many different co-creative partnerships on archetypal intelligences, multidimensional intelligences, all of it. As a friend said earlier today, it covers the whole 9 yards, or as my American friends say, the whole enchilada. So, and our universe is perfect for us. And by perfect, I mean that it's set up in such a beautifully instructed, informed, holographic way that after 13.8 billion years, we're able to be here together, enjoying each other's company, enjoying beautiful food, enjoying love, enjoying play, enjoying inspiration as part of our universe's exploration and evolution and existence. So, as I said before, the first law of information enables our universe to exist, the second to evolve. From its beginning, time must flow. It's the ever-increasing level of entropically expressed information. As I say, time's our universe thinking, space expanding holographically, ever more informational content, allowing our universe, enabling our universe and us as its microcosmic co-creators to evolve. It's our universe breathing. So, I'd like to spend the next 10 minutes just talking about the evidence, not just at the very large scales and the very small scales of all of this, but every scale in between. Because that's where the bulk of the evidence, the experimental evidence and the discoveries are happening. And part of that is showing that underlying all the appearance of our universe, from atomic scales, subatomic scales, up to very large scales, that there are fractal underpinnings. In other words, fractals are geometric patterns, not the idealized ones of the Greek geometers, but the fragmented dimensional patterns of clouds and coastlines. They scale up, they scale down. They're scale invariant, so they're innately holographic. And they manifest the cosmic hologram as of our informed and holographic universe. Now, underlying all of the fractal patternings that we call physicalized reality are super physicalized. And we have to be very, very fluid in a way in terms of how we define physical, super physical, because as we move forward into this expanded awareness, then everything that we call, as I say, energy, matter, space, time, is actually information, consciousness. So we are, all of us, within this thought form, as part of this thought form that is existing and evolving. But the patterning for it is modelled in what's called the complex plane or phase space. That is at a deeper level of reality, a deeper level of informational patterning, a deeper level, if you like, of consciousness playing, enjoying itself. So, for example, the weather, you'll see here something called the Lorentz attractor, and this underlies weather patterns. And as you'll see, this is dynamic. This is not a static pattern. If you actually, just for a little moment, just do this. Do the sign of infinity in front of your eyes, okay? And it also looks a bit like a butterfly's wings, yeah? What you'll notice is that every time you do the pattern, it's never exactly the same. It's within a boundary, but those boundaries vary within certain limits, and every crossing point is different. Now, what that does, because it is dynamic, it allows a sustainability, but it's always different. The weather's never the same every hour, every day, every week, and yet it's within a patterning. And all complex systems are underpinned by these attractor basins. The thing is that attractor basins are sustainable, but they're also on the edge of criticality. They're in critical states. So if you get a situation where a particular attractor is impacted to a level that pushes it beyond its ability to recover, then what you will do is you'll either get a breakdown or, depending on the level of potentiality, you will get a breakthrough to a higher level of coherent state. And I wish I had time and I don't, but that is essentially as co-created partnerships within ecosystems, with the entities and their milieux being co-creative evolutionary partners. That is the story of evolution. Yeah. Now, the fractal patterns in the so-called natural world are examples of coastlines I've mentioned, weather patterns, earthquakes, I'll come back to earthquakes, ecosystems, clouds, river patterns. But there's also fractal patterns that absolutely pervade the so-called man-made world, and this is critical, because this is saying we cannot take ourselves away from the cosmic hologram. We are microcosmic co-creators of its innate intelligence. So what we get are fractal patterns pervading the man-made world, and these are examples: the internet, stock markets, incidents of conflicts. I'm going to come back to that. Growth of cities, social behaviours. In other words, the informational patterns embodied in our universe at all scales are the same, whether so-called natural or so-called man-made. Atomic phase transitions at the electronic scale between metals and insulators show fractal patterning. Ali Yazdani. At the scale of up to 330 million light years, galactic clusters by Morag Scrimgeour and her team have been shown to have exactly the same fractal patterns. Cities, Henry Lynn and Abraham Loeb at Harvard astrophysicist, showed a few years ago that when you look at population densities, whether it's people or stars, cities grow in exactly the same way that galaxies form. Going back to earthquakes, the Gutenberg-Richter power law of earthquakes, called about the Richter scale of earthquakes, shows the relationship between the incidences, the frequencies of earthquakes, and their destructive power. And it is a logarithmic scale. There's no average earthquake, which makes earthquakes so difficult to forecast. What instead you get if you graph the size of earthquakes logarithmically and their frequency, you get this straight line. It's called a power law. And all it means is that an earthquake of twice the destructive power, logarithmically, is 4 times less likely to happen. That's all you can say. Now, human conflicts. Lewis Richardson, in I think 1948, looked at hundreds of human conflicts, including 2 world wars, lots of regional conflicts. And more recently, Neil Johnson and his team at the University of Miami looked at insurgencies in Iraq and Afghanistan. Guess what? This one shows Neil Johnson's stuff, but it shows the same power law plays out in human conflicts as in earthquakes. In other words, a human conflict which has twice the level of fatalities is something of the order, it's a slightly different slope, 4 times less likely to happen. World wars are the outliers, but they're not atypical. Hissy fits, regional conflicts are part of the mix. Think of all the choices we make, individually or collectively, to go to war, and then realise that exactly the same fractal holographic power laws play out in earthquakes. To hold on to. The same dynamic holographic informational patterns that pervade ecosystems also play out through human behaviours. So, for example, as I mentioned, and I'll come back to it in a second very briefly, but entities, biological entities within an ecosystem are co-creative evolutionary partners with the entirety of that ecosystem. And ultimately, within our planetary home of Gaia's biosphere, and not just biosphere, but the atmosphere, the waters, all of it, and not just on Gaia. I've written about in the Cosmic Hologram, in the next book of the trilogy, Gaia, her story, will tell the story of the biography of our planet as a living being. But the point is that everything is interconnected with everything else. Everything is existing and evolving on our planetary home and with our sun and our moon as a trinity of involvement. Even all of the planets of our solar system are involved in this to enable us to be here having this wonderful conference today. I hope that's an agreement. But this plays out exactly the same informational, fractal, dynamic patterns play out through our social behaviours. The way we surf the net, there's been analysis done on not just the internet itself, which is holographic and fractal, but how we surf the net, how and when we use our mobile phones. There's even been experiments done on how we return library books. We return library books fractally. Who knew? Amazing. And key and very important is that our entire universe exists and evolves in a way that is informationally designed for evolution. Again, through the book I go back, the forces, all the forces in our universe are fine-tuned. Lee Smolin at the Perimeter Institute analysed this to 1 part in 10 to the 27. If those universal forces were out by a tiny, tiny amount, our universe wouldn't have even got going, let alone be here. Hydrogen, which was the vast proportion of energy matter at the first moment of the big breath, goes through an incredibly, exquisitely balanced process through nucleosynthesis within stars to get to the heavy elements. And by supernovae, the large stars that at the end of their lives explode, they explode in a terms of frequency and scale that enables interstellar gas clouds to form. If they were stronger or more frequent, again, those would not occur. And they are, as these eggs are showing. This is in the Eagle's Nest, the Eagle Nebula in Serpens. Those interstellar clouds couldn't exist. And after 3 generations of stars, after something like 9 billion years ago, all the nutrients were there about 5 billion years ago to enable planetary rocky planets to form with all the biology needed, water. There's vast ice clouds throughout space, vast clouds of prebiotic molecules, all bathed in a gentle ultraviolet light, not too powerful, just powerful enough to enable the creation, not just of rocky planets, but all of the nutrients ready to enable the emergence of biological beings such as ourselves. And then we move on to emergent complexity. Complexity emerges, we emerge, the whole of our universe evolves from the most simple of rules. You know, people looked at rice, piles of rice and piles of sand. I mean, you know, they should have got out more, I agree, but thank goodness they did, because what we realised that everything develops to a self-organised level of emergence. The rules are there, and they are informational rules. They pervade all of that evolutionary process. It's all evolutionary, it's all informationally driven. And going back to what I was saying about the Lorentz attractor for the weather patterns, yeah, if it goes beyond a certain tolerance, then it will break down into chaos, but then new forms of order are within that chaotic milieu, or it will break through to the emergence of evolved and higher level coherence. And I hope we have time later on today and tomorrow to discuss this at more length, because that's the place I think we're at now. We're at that cusp of breakdown or breakthrough. If we stick with our separate view of reality, then my suspicion is that we'll end up with breakdown. If we actually take all of this on board, all the evidence, all the understanding that reconciles science with universal spiritual experiences and understands that consciousness isn't something we have, it's what we in the whole world are, then I hope and pray we will do enough to do this breakthrough and actually enable our children and their children to inherit a planet that is viable for human experience, and for us as a human species to go on and on and on through this amazing adventure of consciousness. So I've just rushed through this because I'm conscious that we do need to move on. But at emergent tipping points, there's been analysis done of what's called transitional informational signals. In other words, at each point of emergence into that next level of possibility, potentiality, coherence, evolution, it's been found that transitional information shows up within the system. The system itself, the possibility of what it becomes, is actually present at that moment of emergence. Now, ecosystems exist sustainably, but yet near critical states. So their flexibility optimizes their responses to low-level variations in their environment. So we get maximum diversity in a healthy ecosystem with minimum effort of genome reconfiguration. When we look at 4.5 billion years of evolution on Earth, on Gaia, what we see is where there's low-level environmental variations, we get co-creative intra-species interaction. So since for the last 12,000 years, there's been very, very, very low levels of new species developing, because we haven't had to. The environment's been balmy, it's been easy, it's been comfortable. Where there is increased evolutionary change, where those attractors are pushed beyond the levels of their sustainability, then there tends to be a progressive die-out and new species coming forward. But it is the laziest of lazy. It's the maximum benefit with a minimum effort. So that covers us for things like Milankovitch cycles and ice ages. But where there's catastrophic environmental change, such as there was 65.5 billion years ago with an impactor in the Gulf of Mexico, where there's catastrophic environmental change, then, you know, there have been 5 of those that we know of, major ones, over the last, well, since the Cambrian explosion. But each time, even though one of them, called the Great Dying, is estimated to have destroyed 95% of all life on Gaia, there was an immediate response by the Gaian system, an enormous push forward in new speciation. So this is the informational design for evolution at play. It's the maximum flexibility with a minimum effort, but by gum, if you've got an asteroid coming in, you have to make quite a lot of effort. But then you get this massive rush of speciation, which is why we're here, because when the dinosaurs died out, and many other species did, tiny little mammals said, our turn. showed up 65, 66 million years ago. Here we are, punctuated equilibrium. We're now in the middle of a sixth extinction caused by us, pretty much. And we're calling this time, instead of the Holocene, which is the last 12,000 years, the Anthropocene, because it's human behaviours that are affecting. Somebody said to me over the phone the other day, you know about the Anthropocene era? And I thought he said Anthropocene error. And I thought, yeah, it is an error, because if we knew better, we wouldn't have made it an Anthropocene era. So maybe it's time for us to get over that. And this is where I end. This fallacy of immaterial mind somehow coming out of material brain is illusory. The entirety of physical world is literally all-pervasive informational processes, including us. Duality, I'm happy with any words we want to use, and to play out the reflections of each other on holographic scales, whatever we want to call it. But I would suggest that we're now remembering, or able to begin remembering, our unique diversities, yet within unity awareness of the whole world view. All we call physical reality and realities, in my perspective, is infinite and eternal cosmic mind, exploring, experiencing and evolving on multidimensional and myriad levels of consciousness that I've explored personally and directly for 60-odd years, and including through finite thought forms within universes, universe souls. Evidence is now reconciling science with universal spiritual experience and consciousness to show that information's reality. It is bit, mind is matter, and consciousness isn't what we have, it's what we and the whole world are. So instead of science of consciousness, I think we're hopefully a step beyond that to conscious science. And we are microcosmic co-creators of our universe soul, microcosmically playing out through us as sages, as shamans, as seers. If information is the notes, perhaps we can consider consciousness as the music of our universe. That's the book. Okay, thank you very much. Will you please be kind to me?
Okay, I've got two questions here. One is, how would you define information? What is information? And the other is, where does free choice come into it?
I love it. Thank you so much.
Not trivial.
The reason I have the hyphen in the book's subtitle of information is it's patterned information. You can think of basic data, and basic data in our technologies is expressed as bits, digital bits of information, okay? And if that data is put together, you can analyse it, you can review it, you can do all sorts of things with it, okay? The information that underpins all our technologies, all our virtual realities, all our holograms, is exactly the same as the digitised information that is reality. However, reality does something more than just amalgamate information. It patterns it with purpose and intention, and exploratory promise, and possibility for evolutionary experience. So what you're doing is you're sort of taking the sort of complexity levels up. But our universe began with that informational algorithms that we call the laws of physics that we now need to expand in informational terms. But I said right at the end, one way perhaps of considering this as a metaphor is, how many of you guys are musicians? Okay, so you know that we don't make music without having some notes. So if we consider information as the notes of music, then as Martin plays some Bach, there's lots of notes in Bach, But that beautiful music is made up of basic notes of information. We can consider that information is the notes, then consciousness, at myriad levels of awareness, is the music. You know, we are a symphony. We are a symphony of consciousness, and our universe is an informed, holographic song, a universe. Yeah? Now, I know that, you know, I don't want to parse this, because one of the things is consciousness is a very, very broad church. So for me, our universe is conscious. Everything for me is consciousness. You know, it's not something we have, it's what we and the whole world are. And I'm sure other people take different views of that, but I think that's important. You asked one more question. Free will. Okay, free will. Well, when you see that conflicts play... Okay, when you see that...
Short,
okay, when conflicts play out in the same way that earthquakes, I will turn that question back to you. I would turn that question back to you. When conflicts with all our choices play in exactly the same way as earthquakes, we probably need somebody else. We'll talk about it over lunch because it's too long to cover.
Have you got the microphone? If you've got the microphone, put your hand up. Are there two microphones? Well, he's got a microphone, right, okay. So the next microphone goes over there. Okay. So let's have the next question ready after the next one's been asked. So one microphone
Jude,
ahead.
Tim Holding.
Hi, Tim.
I'm going to challenge you at quite a profound level on your concept of entropy. My understanding is that it's the erasure of information which is consistent with increasing entropy. Now, that may sound a little bit problematical
it's not, it's not problematic.
But it's how physicists do see information and its erasure fitting in with increasing entropy. And secondly, you've reduced the cosmos to me to an algorithm.
I hope not.
That's how it felt, and I'm not prepared to accept that. I'm going to challenge you again and say I don't think you've explained anything, because I believe there is algorithm, of course, but I believe that there is something way beyond algorithm, and that's exactly the point, or at the point, where there can be a unification of our experience as human beings and what we measure in science.
I completely agree with you, and I'm only surprised that you think that I've done that, because I hope over the last hour, well, you may disagree, Tim, and that's fine, but what I've tried to do is to show that what we've been trying through this last 40 years of reconciling science and consciousness is actually on our doorstep. And we're like kids, in my view, at a new school. We've just shown up at the school. We have so much to learn. I say in the book this is a work in progress, but this is the direction of travel. And so for me, I keep reiterating that consciousness isn't what we have, it's what we and the whole world are. But the point with science is that there are many books on consciousness. There are many books that try and relate consciousness to quantum physics, and they don't do it, because what they're missing is the understanding of the informational aspects that expresses itself in quantized ways. So this is a work in progress. This is a going forward. But the last thing I would ever want anyone to take away is to just perceive our universe as a large computer, because that's not what I'm saying. What I am saying is that the laws of physics are innately informed, and our universe is holographically manifested to enable consciousness at many, many different levels to exist as a universe, as a universal entity, and to evolve into more and more self-aware microcosmic perceptions of its innate intelligence.
Yeah. Just on the conservation of information theme, we have to accept that the information stored on the event horizon of a black hole, there's only three types of information. That's the mass, the charge, and the spin. So there's a difficulty that I have with that, in that we could be consumed by a black hole, and the information that we would be left with would be, hello, the mass, the charge, and the spin. So again, it doesn't explain.
No, I never said it did.
The depth of experience of our human condition.
I never said it did.
No,
all I said was that I understand that.
As far as Bekenstein Hawking.
Indeed, and perhaps you and I could go and talk over lunch because you're clearly pushing things forward. But I can answer all of that.
Okay, Richard.
I'm so glad you said wow at the end of that talk, David, because that's exactly how I felt. For my rather unscientific and simple mind couldn't follow quite a lot of what you said, but I did love the metaphor of the origin of the universe being a big breath rather than a big bang, and also the metaphor of information being the notes and consciousness being the music. That helped me a great deal as well. But as I said, a lot of it I just couldn't get my mind round at all. But there are two questions which seem to be paradoxes to me. One is, when I look into the heavens, how can I possibly imagine the universe as flat? And the other question is, because on one of your screens it said finite and closed in space-time, and underneath it said space expands.
Yes.
How do you bring those things together?
First of all, let me take the second one first. If you think of a balloon, and you forget the fact that you can blow up a balloon and so it's not a wholly closed system of itself, you can see that as you blow up a balloon, the balloon is still a closed system. And I'm using that as a partial metaphor because obviously you're putting the blowing into it. But essentially what that says is that the energy matter of our universe is conserved, is universally conserved. And we can see that in many different ways, but the fact of the viability of the laws of physics actually point to that. The other question was the first question was?
How space expands and yet it's finite.
Yeah, I sort of did that with the balloon, but the flatness, you said, how can you look up in the stars and say space is flat? What scientists mean by flat is Pythagoras. In other words, if you've got a flat piece of paper, a triangle has 180 degrees on it, okay? If that piece of paper is turned that way or turned that way, then the angles of a triangle would not be 180 degrees. There'd be something either more or less. We know that the angles of a triangle on a universal level are 180 degrees, otherwise E would not equal mc squared. So that's what scientists mean by flatness.
Eddie, I think, and then let's take another next microphone going over there. I know, I've got Eddie here. Anyone else, Bernard? Yeah? Eddie.
Thank you very much, Jude, for that. And I was delighted to hear the big breath and not the big bang or the big noise. After all, the origin of the word Brahma is to breathe out.
Exactly.
And Vishnu to pervade. So having breathed it out, I pervade it with my essence. Yeah. But my question is, the entire ancient wisdom, occult, esoteric tradition talks of numberless universes, cosmic slumber and cosmic awakening, pralaya, manvantara.
Yeah.
So do you really regard, I'm not saying you do, question, our universe as just the only one?
No,
Or can you also relate it, big question, to multiverses and the idea of big bounce, as the word is now?
Yes.
And the Hermetic axiom, which always plays in.
Yes, is the answer. I mean, the whole concept of the universe is right at the edge of any sort of even theoretical, let alone experimental viability. But there are two things I write about in the book which may prove helpful. One is how universes themselves at the end of their life cycles come to completion. And the other is how new universes are birthed. And very much of that view that the numberless universes within the infinity and eternity of cosmic mind. So the one that suggests how new universes might be birthed is instead of a black hole scenario, white hole, but it is a big breath, is something called the ECKS extension to general relativity. And what this says is that at the most extreme conditions, either within a black hole or within a supermassive black hole, the intrinsic torsion of subatomic entities has an effect that essentially almost buds new universes off. So that's one possibility of birthing process. The completion process is something that Roger Penrose has recently come up with, called the CCC hypothesis, which is conformal cyclic cosmology. And the idea of that is that because if you consider universes as thought forms and consider them as holographically manifest, they can scale up, scale down. So Roger, through a fairly complex mathematics, has suggested that there is a sort of a rescaling process at the end of the information entropic process. Yeah, so that when a universe gets almost to absolute zero, which of course ours will, it's at 2.73 degrees now. It started off at 10 to the 32 degrees K. As it comes to very close to that point, then there could be a process that actually, in a beautiful way, and going back to the breaths of Brahma and the ancient wisdom, that the out-breath of the big breath, and then the understanding, the consciousness, the learned awareness, just then gets dissipated into the cosmic plenum. So there's this grand perspective of universes and universes and universes as finite thought forms in the mind of Brahma, of God.
Thank you. Over here. And then can the next one go over to Bernard? No, we've got... Bernard got a microphone?
Yes.
Oh, okay. Yeah, that's fine. Excellent.
Thank you very much. I agree with almost everything you said, but I wanted to elaborate on the point which actually was just raised a few moments ago, because I thought what you said wasn't particularly clear, but maybe you do mean what I'm going to say. The point is that the second law of thermodynamics, which says that the entropy increases, on the face of it, of course, that implies that the information decreases. Now, but what happens, the insight we now have from nonlinear theory and chaotic systems, is that what actually happens is that as time goes on, you get pockets of increasing order, increasing information. And the reason that isn't inconsistent with the second law of thermodynamics is because actually the total entropy in the universe does increase, but you're getting these pockets of what I call the pyramid of complexity.
Yep.
So your second law of infodynamics or whatever, that's fine, providing you make it clear that's what you mean, because on the face of it, that is incompatible. So with the second law of thermodynamics, but that's fine as long as you meant it in that sense.
Absolutely, and we are talking about on a universal level.
That's fine, but the information does increase, but only in a decreasingly small fraction of the universe. And the other thing is, I have to say, although I'm a conventional cosmologist, I love the idea of the big breath as opposed to the big bang. I'm actually a great proponent of the... I shouldn't say I'm a great proponent. I'm a proponent of the cyclic model, which, of course, if you think of the Big Bang as a big breath, is just the breathing model of the universe. And I actually prefer that to Penrose's conformal concept.
I mean, this is the point we don't know at the moment. This is a direction of travel and we don't know. I think the problem with the cyclic model is an information entropic issue. And I'd love to discuss it more. And I think with any of these things, as I said right at the beginning, we're on the theoretical absolute cusp of that and the multiverse scenarios. So I think, the CCC and the ECKS are what do they call interview candidates.
Ultra speculative at that level.
Ultra speculative, yeah. Absolutely. Whereas what I've been presenting now is far more evidenced, obviously. Thanks, Bernard.
Right, we'll take one more. Who's got the microphone? We'll take one more question here, and then we'll bring Ravi up, and then we can continue. Could you give your name?
Oh, my name is Fiona Hope, and I'm not a scientist. I'm a musician. I understand that we're coming to the end of the Anthropocene era, and there's going to be a complete breakdown. But you said, I hope and pray that we will have a breakthrough of consciousness. What do you mean by pray? And do you...
Good question.
do you actually believe that if we pray for a new consciousness, we will achieve it?
I love that question, Fiona. As well as a cosmologist, I describe myself as a healer. Not because I impose healing on anybody, but I do share with them and hopefully help them to undertake their own healing. And for many years, I have been convinced by the power of focused, intentional compassion into situations. I've worked in war zones and many other situations. And so, you know, for me, it is about intention. It's about coming together. It's about recognizing we are co-creators, consciously or not, of our realities, to microcosmic conscious co-creators. So, yeah, I'm happy with prayer.
Thank you. Well, we might build on that a bit later in the conference. So I'd like you to join me in thanking Jude for her brilliant presentation.
Thanks, everyone.